The CBO estimates that we are on track to run $2 trillion annual deficits by 2028. The CBO also found that we will run $82 trillion in total deficits over the next 30 years. We need to focus on reducing government spending wherever we can. So from what I understand, the main benefit to using composite materials as opposed to steel or concrete is the reduction in maintenance cost over the long term. So my first question for each of you, is there any data on what kind of cost savings can be expected over 20 or 30 years by using composite materials for various infrastructure projects? Dr. Chen?
My colleagues from the industry would have more specific figures on the actual cost savings, but we are very much aware of studies and existing installations that have demonstrated great reductions in installation costs, impact on the economy in regards to road blockages and delays, as well as maintenance and repair, as well as replacement over the lifetime of the structure.
Okay.
As I stated in my testimony, we have rehabilitated over 100 structures across the country from West Virginia University's Constructed Facilities Center. I'll give you two examples, and I'll shut up. One of them is there's a East Lynn Viaduct. We rehabilitated it for about 20% of the cost of replacement in Parkersburg, West Virginia. When I took that job, they said if it survives 5 years back in 1999, they said they would be happy. Last year, we collected the data, and it looks brand new. The second example I like to quote, which I have done the rehabilitation renovation part, was for Army Corps of Engineers. Again, we were able to rehab that complex bridge system with $120,000, while in fact it would have costed $4 million to replace it. So the list goes on. I'm not going to stand here and talk about it anymore, but I'll be very happy to supply you with all the cost data and also the durability data if you need.
Your remark about the main benefit of FRP being reducing maintenance costs, I think there's truth in that FRP is a very effective repair material. We're seeing this used in sheet products that are put onto reinforced concrete structures, and it's one of the least expensive ways to add strengthening in many cases. I'm not so sure I would say that that's the main benefit of FRP, though, because I think having a landscape for design where you have multiple materials being used, a real portfolio of materials, is where we could get even more benefit in the future. I think there's been some limitation to have civil engineering organized in silos, where you have the reinforced concrete community, the structural steel community working somewhat independently, and FRP wondering how do we fit into this situation. And I think there's probably a higher calling to try to figure out how to give all materials sort of equal access. In some respects, engineers should be material agnostic. I don't really care what particular material, I want to get a result. And having all those materials available will be the best benefit of having FRP in the game.
Okay, and Mr. Weyant, before you answer that question, perhaps with the time left as well, you can answer the question of what would the cost benefits of replacing or restoring electric lines with FRP composite poles be?
On the electric line, it's more in the reliability, how they withstand a lot of the storms. We see that a lot with a lot of the electric companies. They're understanding that value now by investing in composites for that reliability. As far as the life cycle, I look at it a couple ways. Not only on the maintenance side, it's also the installation side. We have seen cooling towers, marine markets with sheet piling, and also in the utility industry, that we have seen probably 30% overall life cycle cost savings when using composites.
Thank you. My time has expired.